Ahora sí, estamos online de nuevo. Para continuar con el meetup de hoy de julio, de hoy día, voy a presentarles a Raquel Condori. Ella va a estar de anfitriona de aquí en adelante. Sin más preámbulo, bienvenida Raquel la audiencia y todo el meetup está a tu cargo ahora.
Gracias, Carlitos. Muy buenos días a todos. Soy la ingeniera Raquel Condori Palomeque y darles a todos la bienvenida al Java Virtual Meetup de julio. El día de hoy vamos a tener 3 grandiosas expositoras, una nacional y 2 internacionales desde la India y el Reino Unido, que van a estar compartiendo su conocimiento y su experiencia con todos nosotros. Así que siéntanse libres de postear sus preguntas en slido.com. Vamos a dejar el link en los comentarios. Y también anunciarles que el día de hoy vamos a regalar premios a los 3 primeros lugares que respondan el quiz al final de las 3 charlas. Así que tomen apuntes, tomen mucha atención y participen. Así que comiencen los Juegos del Hambre. Quiero dar la bienvenida, tengo el agrado de presentar a la ingeniera Jazmín Cusi, quien es entusiasta de la tecnología y con un particular interés en el desarrollo de test automatizados. Querida Jazmín, bienvenida.
Muchas gracias, Raquel. Es un gusto compartir, estar presente en las charlas que han programado para este mes y me siento honrada de compartir el escenario con, como dicen, los grandes expositores internacionales. Así que gracias por todo, el Bolivian Jack. Bueno, entonces, si no tienen alguna objeción, voy a comenzar con la presentación, con el tema que voy a tocar hoy. Muy bien. No sé si pueden ver mi pantalla en este momento.
Todavía no se ve, Jazmín.
Ok, esperemos un poquito más entonces. ¿Ahora?
Todavía no.
Ok. Vamos. Ok.
Ahora sí, creo que ya está cargando.
Okay. Ya debería estar. Genial.
Ya está.
Ok, muy bien. Entonces, lo que quiero mostrarles hoy es algo sumamente interesante, que es el concepto de Mutation Testing. Les voy a mostrar en este tiempo que me han concedido cómo aplicar el Mutation Testing a algún proyecto que ustedes tengan en Java. Y este reporte que se va obteniendo, que se va a obtener a partir de este análisis, integrarlo con Sonarqube. Es algo sumamente interesante. Entonces, lo que quiero tal vez recalcar es, primero, ¿qué es el Mutation Testing y cuándo es ideal aplicarlo? Y para dejar en claro eso, pues aquí tengo un pequeño ejemplo. Un pequeño método que calcula un factorial. Ok. Uno tiende a pensar que el code coverage, sí, a pesar de que es una excelente herramienta de análisis que nos permite saber a partir de un test qué líneas se están ejecutando, pues a veces tiende a no dar un feedback completo. Por ejemplo, en este caso, el caso que les estoy presentando justo en la parte inferior derecha, pues es un caso sumamente extremo que puede llegar a suceder por un error humano. Quién sabe qué es lo que sucedió. Tenemos un pequeño unit test que calcula el factorial de un número determinado, pero ¿qué ha pasado? Nos olvidamos del assert. El code coverage como tal no nos va a decir si es que eso está faltando, falta una verificación o no. Simplemente nos va a decir se ha ejecutado tales líneas y todo bien. Entonces, llega a surgir esta duda. y nos ponemos a pensar qué es lo que ha pasado. ¿Estoy escribiendo correctamente mis tests? Tal vez un test es suficiente. Si es que no, ¿qué casos me están faltando? ¿Cómo es que puedo llegar a conocer si es que la calidad de mi unit test es la mejor? ¿Existirá realmente una herramienta que me permita conocer la respuesta a todas estas preguntas? Pues sí existe, y esa es la alternativa que tenemos nosotros. Perdón, para responder a esas preguntas, nosotros tenemos el concepto de Mutation Testing. Por ejemplo, para el caso anterior, eliminamos un assert. Vamos a ver cómo es que el Mutation Testing nos ayudaría a identificar que un assert nos está faltando. Ok, en un flujo normal, nosotros tenemos un código, un método, digamos, como el factorial, al cual le hemos diseñado ciertos unit tests y nos aseguramos de que esos unit tests pasen. Ok. Lo que hace el Mutation Testing es insertar cierto tipo de modificaciones muy pequeñas, casi insignificantes, al código que nosotros queremos analizar y a partir de ello generar mutantes. ¿Qué son los mutantes? Son simplemente el código el cual se ha modificado algo. Lo siguiente que se hace en este análisis es ejecutar estos mismos unit tests que tenemos contra este código modificado, esperando que esta suite me diga que hay algo que está mal. ¿Por qué? Porque estas modificaciones se consideran como bugs artificiales, fallas intencionales. Y ante la existencia de bugs, nosotros queremos que nuestros tests nos digan que algo está mal, que algo está pasando, que tenemos que revisar esto. Ok. Idealmente lo que se espera de esta ejecución es que estos tests fallen. Si los tests fallan, perfecto, nuestra suite es robusta lo suficientemente, por lo menos como para sobrevivir a estos bugs que hemos generado. Pero esto no sucede todo el tiempo. Y a veces nos damos cuenta de que alguno que otro caso se nos ha pasado. Tal vez no lo hemos pensado en el momento o tal vez la falta de tiempo nos ha hecho ignorar que esto podría ir más allá de solo unos cuantos tests. Ok, en base a esa respuesta nosotros podemos identificar qué es lo que nos falta. Ahora vamos a ver un poquito más a detalle de qué se tratan estos mutantes. ¿Qué son estas pequeñas modificaciones? Ok. Las modificaciones son tan absurdas como cambiar el valor de una constante. Si tenemos algo que se inicializa tal vez en 3, no sé, lo volverá a 2 y veremos qué sucede cuando se altera esto. Se cambia algo tan simple como una condición de mayor a menor, de mayor a menor, de mayor o igual a menor, tal vez de una igualdad a no sé, a un valor ahora se cambia a un valor distinto. Se puede modificar el tipo de retorno de un método. Por ejemplo, si estoy retornando un entero, digamos, una sucesión de sumas, ya me lo cambiará directamente a 0 o me lo cambiará directamente a 1 y verá si es que nuestra suite está preparada para lidiar con ese tipo de cambios. También lo que puede hacer una mutación es reordenar o eliminar líneas de código, duplicarlas, y tal vez gracias a eso nos demos cuenta de que hay líneas de código que no son necesarias que estén ahí o sí son sumamente esenciales y hagan fallar todo. Entonces, y por último, claro está, alterar operaciones aritméticas, que es algo como cambiar una suma, una resta, una multiplicación, una división. Ok. Y existen, por supuesto, muchos más tipos de mutaciones que se pueden aplicar a diferentes tipos de proyectos dependiendo de la complejidad del código que estemos manejando, las estructuras que estemos manejando. Pero para ilustrar un poquito de lo que se tratan las mutaciones, pues tenemos estos ejemplos. Y para entender un poquito mejor de lo que lo que sucede cuando se aplica Mutation Testing, pues volvemos al ejemplo inicial, calcular el factorial. ¿Qué tipo de mutaciones podrían introducirse en este método? Ok, la primera que hemos visto, alterar el valor de una constante que se inicializa. Ok, en un principio se estaba inicializado en el valor 1, pero la mutación dice, ¿qué pasa si se inicializa en 2? Ok, sabemos que esto va a alterar a la multiplicación y directamente a nuestro resultado. Ok, entonces con esta modificación esperemos que nuestro unitas pueda ser capaz de detectar esto. Siguiente. Hemos visto que se pueden alterar los tipos de condiciones. En este caso, nosotros estábamos esperando en un principio que y llegue hasta n y ese es su tope. Pero no los cambió. Entonces, ahora la condición dice que y debería ser mayor que n. Altera completamente el comportamiento del for y por ende al resultado también. Seguimos con la alteración en el for. Ok. En este caso estamos cambiando el valor incremental de y por uno que decrementa. Tal vez entra solo una vez a realizar la multiplicación y luego no vuelve a entrar más. ¿También afecta? Claro que sí. Siguiente que podemos aplicar también es alterar el valor en el que se inicializa y. Inicialmente era 2, ahora es 3. ¿Afecta? Muy cierto. Siguiente. ¿Qué es lo que pasa si es que la condicional se vuelve true? Entonces entraremos en un loop infinito. Ok. Muchas de las herramientas que ejecutan este análisis tienen este timeout para las ejecuciones. Entonces, si nos encontramos con este tipo de casos, pues gracias al timeout no tendríamos problemas. Y este caso se marcaría como fallado. Pero sí es interesante saber que es posible cambiar el valor de una condicional directamente a true. Siguiente caso, ¿qué pasa cuando todo es false? Tal vez, bueno, en este caso nunca va a entrar el for y directamente va a retornar este valor. ¿Afecta de gran manera? Claro que sí. Otro tipo de mutación. ¿Qué pasa cuando negamos el resultado de esta condicional? Si en un principio era true, pues será false, y si era false, será true. Ok, ¿afecta? Por supuesto. Siguiente. Tenemos otro mutante que se trata de cambiar una multiplicación por una división. ¿Afecta directamente al comportamiento del factorial? Claro que sí. Nosotros no queremos dividir cuando calculamos el factorial, entonces esperamos que nuestros unitas puedan detectar esto. También habíamos visto esto. Se puede alterar el valor que se retorna. En este caso, directamente nos está retornando un 0, ya no el valor de la multiplicación. Ok. Debería ser posible detectarlo, ya que 0 ni siquiera está contemplado como un resultado de un factorial. Y también tenemos el caso en el cual retornamos el resultado más 1. ¿Qué pasa en esta situación? Debería ser posible detectar esto. Entonces hemos visto que para un solo método hemos generado 10 mutaciones y eso que nos faltan muchas más. Esto parece un poquito moroso, tal vez en algunos casos complicado y también algo que consume bastantes recursos en cuestión de tiempo, en cuestión de recursos humanos. No suena pero por suerte tenemos herramientas como Bit que nos ayudan a hacer este proceso automático. Esta herramienta nos genera los mutantes, los ejecuta y nos entrega un resultado que podemos interpretar. Ok. Esta es una herramienta muy popular para hacer Mutation Testing porque tiene reglas dentro de sí mismo que son estables y nos permiten analizar la cobertura de nuestros tests. ¿Qué es lo que hace Pit? En 4 pasos hace lo que acabamos de ver anteriormente. Toma una clase, la analiza, genera sus mutantes posibles, ve para esa clase la suite de unitas que se tenga, luego, esto es algo bastante importante de comprender, genera, a partir de esos mutantes generados, los cambios que haya generado se los inserta a nivel de memoria, a nivel de bytecode, no en el código mismo. Así que esto jamás va a afectar a nuestro código. Una vez insertados estos mutantes, manda a hacer la ejecución de estos tests que han sido seleccionados en el paso previo. Y con todo esto nos construye un reporte que nos permita ver si los mutantes que ha generado han sobrevivido o han sido eliminados, qué es lo que ha pasado, si es que han sobrevivido, dónde están estos mutantes, de qué se trata, qué son. Genial, suena interesante. Y lo mejor de todo es que esta herramienta tiene un plugin que puede ser integrado a Sonarqube. Sonarqube es una plataforma muy popular, una herramienta que nos permite hacer inspección a nuestro código. ¿Cómo es que hace esto? Tiene reglas predeterminadas que se han construido en base a ciertos estándares que debería seguir el código que estamos construyendo. Entonces, Sonarqube nos permite analizar, en pocas palabras, la calidad del código. ¿Qué nos va a decir Sonarqube? Si tenemos código duplicado, estamos cumpliendo con estándares específicos, nos dirá el code coverage a partir de nuestros unit tests, nos dirá la complejidad de nuestro código y, lo más importante, nos mostrará bugs potenciales. Este es un reporte muy completo de nuestro código y suena ideal integrar el análisis, el reporte de análisis que hayamos hecho a partir de las mutaciones a todo esto. ¿Y cómo se hace esto? Es sumamente sencillo. Como parte de la configuración, una vez teniendo ya un Sonarqube funcionando, nos dirigimos al marketplace y buscamos el plugin de nombre Mutation Analysis, que es por el momento el único que existe. Solo existe uno, así que no hay donde perderse. Y bueno, tenemos que tomar lo que tenemos. Es recomendable y está dentro como parte esencial en la página del plugin, crearnos un perfil aparte de los que tenemos por defecto. ¿Por qué? Nosotros queremos todas las reglas del Mutation Analysis en Sonarqube, pero a la vez nosotros también queremos tener las reglas que ya existen para Java, para el análisis de código, corriendo. Entonces queremos ambas cosas. Y lo mejor es crearnos un perfil que extienda las reglas que tenemos de Java y ahí agregar las reglas que existen para el análisis de mutaciones. Esto es sumamente simple. Una vez que se le da al botón de activar más, buscamos las reglas que coincidan con el tag Mutation Operator, que estén en el repositorio de Mutation Analysis y que están listas para ser ejecutadas. Todo esto mediante un bulk podemos integrarlo. Una vez hecho esto, pues nuestro perfil está listo para leer nuestro análisis e integrar este reporte a lo que ya habíamos visto. Ahora, este perfil puede estar configurado por defecto, puede ser configurada solo para utilizarse en un solo proyecto. Eso ya dependerá mucho de cada quien y de cómo desee realizar todo esto. Ok. Y de parte de el proyecto en el cual querramos hacer este análisis, pues se necesita añadir un plugin que es propio de It's. Es un plugin sumamente sencillito. Este es para Maven, pero también tiene uno propio para Gradle, si no me equivoco. Integrar, una vez adicionado a esto, podemos hacer nuestro análisis de mutations. Y algo importante que recalcar es que el plugin como tal necesita que el formato, el output format esté en XML sí o sí. Si esto no existiera, pues nos devolvería un reporte en HTML que es también sencillo de leer, pero lo que queremos hacer es integrar ese reporte a Sonarqube. Entonces, para este caso necesitamos que esté en XML. Es algo muy importante y tiene que estar ahí o vamos a tener problemas con la integración. Y algo también muy útil de recalcar es que podemos elegir con este parámetro en qué clases queremos hacer el análisis. Muchas veces no queremos hacer un análisis en todo el proyecto, tal vez solo en clases nuevas o que están siendo modificadas. Entonces, este parámetro nos permite elegir qué clases van a ser víctimas del análisis, digamos, y las que no estén mencionadas, pues no se tocarán. Si esto no existiera, entonces el análisis se haría en todo el proyecto. Eso es muy útil de saber. Ok. Y para que vean más o menos cómo se hace, cómo se saca este reporte y cómo se va a ver en Sonarqube, pues tengo una pequeña demostración. Es sumamente sencilla. Lo que tenemos aquí es un proyecto sumamente simple en el cual vamos a registrar usuarios a una pequeña lista y cada usuario solo tiene como atributo un número de identificación. Y vamos a someter el análisis. Vamos a comenzar el análisis con un solo test que básicamente registra un usuario y verifica que haya sido registrado exitosamente. Ok, aquí ya tengo mi línea de código para hacer el análisis. Comenzamos ejecutamos y estoy, bueno, aquí podemos ver cómo es que Pet está leyendo la clase, viendo qué mutations pueden ser introducidos y ejecutando nuestro test contra estas mutaciones. Esto suele tomar un poquito más de tiempo, ya que, como hemos visto, son bastantes casos los que se genera para una sola cosa. Entonces, es esperado que tarde algo. Veamos. Ya estamos por el final. Sí. Ok, concluyo. Vamos a ver cómo es qué es lo que hemos obtenido el resultado. Ok. Lo más notorio aquí es que tenemos 7 bugs. Vayamos a ver de qué se tratan esos bugs. Como se puede ver, son puros mutantes que han sobrevivido. Vayamos a ver dónde están esos mutantes que han sobrevivido. Dentro de Measures vamos a poder encontrar la sección Mutation Analysis si es que hemos configurado todo correctamente y podremos ver también la cobertura en cuestión de mutaciones que hemos obtenido. Aquí tenemos el resultado y nos dice que tenemos 7 mutantes sobrevivientes en total y hemos matado 20 con solo un test. Genial. Vamos a ver cuáles son los sobrevivientes. aquí tenemos otro código y aquí tenemos uno. Dice que la condición del if ha sido reemplazada con falso y el test no se ha percatado. Muy bien. Siguiente. Se ha removido la llamada en constructor y tampoco el test se ha percatado. Ok. Siguiente. Hemos cambiado la condición boundary, justo esto, y tampoco se ha percatado el test. También se ha reemplazado la condicional directamente por un true y no ha habido, el caso que tenemos no ha fallado. También se ha reemplazado por falso y tampoco se ha percatado de este caso que tenemos. Ok. Ojo de buen cubero, podemos ver que necesitamos más tests. ¿Por qué? Porque nosotros no queremos usuarios que sean nulos. No queremos usuarios con números de identificación nula. Y tampoco queremos usuarios con un número de identificación negativo. Ok, tenemos 3 nuevos casos que añadir. Justamente los tengo por acá. Ok. Vamos a añadir los casos a nuestro compendio de tests. Y vamos a ejecutar esto una vez más. Una vez más, sabemos que esto va a tardar un poquito más de lo que se espera. Generalmente, esto depende mucho del tiempo de ejecución de cada compendio de unit tests. Y del código, por supuesto.
Querida Jazmín,
¿Sí?
¿podrías aumentar el tamaño de la fuente
Claro que sí.
del código? Gracias.
Vamos a ver. Digamos un 18. No sé si ahí se puede ver mejor.
Sí, está mejor. Gracias.
Bien. Ok. Habiendo adicionado estos 3 testes nuevos que hemos visto que faltaban, pues vamos a ver cómo resultado nuestro análisis ahora. Ya tenemos solo 2 bugs. Ok. Estos 2 bugs son justamente 2 mutantes que han sobrevivido a pesar de todo. Veamos qué es lo que ha pasado con esos 2 mutantes. Ok. Tenemos todavía un problema con este if que nos dice que un boundary aún ha sido cambiado y no se ha detectado. Ok. Y otro por acá que dice que nuestro return ha sido reemplazado por un valor true y no se ha percatado el test. Muy bien. Tenemos 2 nuevos tests que añadir. El primero, y es algo que no nos hemos percatado en principio, es que nosotros no queremos un usuario con un ID 0, porque eso no existe. Entonces vamos a añadir ese caso y vamos a añadir un caso nuevo en el cual vamos a verificar el return de este método que verifica si un usuario está registrado o no. Esto también ya lo tengo preparado acá. Añadiendo esto, procedemos a ejecutar el análisis una vez más. Y con esto deberíamos haber cubierto todos los mutantes que nos han surgido. Habiendo empezado con un solo unit test, pues hemos llegado a complementar bastantes casos que tal vez en un principio no los hubiéramos pensado, o que tal vez sí, pero algún caso tal vez se nos hubiera escapado hubiera provocado un problema futuro. Y gracias a este análisis de Mutation Testing, pues, bueno, lo hemos encontrado a tiempo. Ok. Vamos a ver. Esperar que termine de correr el análisis. Y ya concluyó. Muy bien. Ok, vamos a verificar una vez más. Ya no tenemos alertas de bugs. Vamos a ver el análisis de mutación. Y sí, genial. Llegamos a un 100% de coverage. Hemos matado las mutantes que se nos han presentado. Todo bien. Ahora volvamos a la presentación. Algo muy importante de recalcar es que a pesar de que hemos obtenido un 100% de coverage con estas mutaciones, pues no podemos decir libremente que el código que tenemos está libre de bugs. Eso no existe. Esta herramienta simplemente es una especie de barrera para evitar que algunos bugs se manifiesten después. Tal vez muy tarde cuando llegue al cliente. Pero no podemos decir que este reporte esté libre de bugs. Simplemente que a las mutaciones que se han encontrado, pues las hemos eliminado. ¿Ok? Habiendo visto ese ejemplo, pues necesitamos mencionar algunos casos especiales que tenemos que tomar en cuenta cuando aplicamos el Mutation Analysis. El primero, por alguna razón, nosotros, como en el caso de este ejemplo, terminamos con una estructura similar. Y es en la cual tratamos de evitar que un método que consume demasiados recursos se ejecute innecesariamente. Por alguna razón de la vida, terminamos con la solución de que un if es...
Querida Jazmín,
¿Sí?
Perdón, tenemos 5 minutos más.
Ok. Listo. Entonces, nos encontramos con este tipo de casos, en los cuales vamos a tener mutantes sobrevivientes que no vamos a poder eliminar siempre. Por ejemplo, en este caso, si cambiamos la condicional de este if, va a salir un mutante. Si cambiamos el tipo de retorno que tenemos acá, va a salir otro mutante que tal vez no podamos eliminar. Entonces, necesitamos ser un poquito flexibles cuando se trata del mutation coverage, porque a veces hay cosas que no esperamos que sucedan, pero suceden. Y hay tipos de mutantes que necesitamos tolerar, tal vez porque este concepto aún no contempla ese tipo de soluciones. Entonces, tal vez un 90 o 95% es aceptable y marcar esto como esperado también. Y otro de los casos en los cuales tenemos problemas es con los enums. Son inicializadores estáticos que se cargan solo una vez, en los cuales no importa si es que introducimos mutantes, pues jamás van a tener efecto en nuestros unit tests, porque justamente se inicializan solo una vez. Entonces se trata de evitar ese tipo de cosas. Si tenemos ese tipo de estructuras, pues tal vez es bueno filtrarlas con el parámetro que hemos visto previamente. Sí, con esto ya hemos concluido la presentación y tal vez mencionarles que muchas veces nosotros nos desanimamos de aplicar este tipo de análisis solo porque sí es muy cierto que consume mucho tiempo. Hemos visto en el pequeño demo que hemos tenido, que para una sola función de registro de usuarios, pues hemos tardado 1 minuto y eso es bastante para muchos, pero bueno, eso no tiene por qué desanimarnos, ya que esto tampoco se necesita correrlo para cada commit, sino solo para cuando tengamos modificaciones fuertes a nuestro código o unit test que querramos, mejorar. Así que, bueno, gracias por su atención y cedo la palabra a mi compañera.
Gracias, querida Jazmín, por la exposición de Mutation Testing con Sonarqube. También recordarles a todos que sigan participando, que participen con sus preguntas en slido.com. Al final de las 3 charlas vamos a tener un quiz para que puedan ganarse los premios de nuestros auspiciadores. Y tengo el gran placer de presentar a Mala Gupta desde la India. Ella es una developer representante de JetBrains, es la fundadora de eJavaGuru.com, es un Java Champion, escritora de varios de programación y es una oradora internacional. Hi, dear Mala. What an honor having you with us. The Bolivian Java community welcomes you, and we are so eager to learn from you. Please go on.
Thank you so much. Thanks for having me.
So you can start with your presentation. Could you share your screen?
Yes. Can you see my screen now?
Oh, yes, it is loading.
Okay.
Okay, I can see it.
Okay. So my internet connection is having some issues. So I'll turn off my camera during the presentation. I'll turn it on towards the end of the session.
Okay.
Okay. So hi, everyone. Thank you so much for having me and for joining in for the session today. I'm not sure because I don't understand the language. I was just introduced in, so I would have a quick introduction about myself. I work as a developer advocate with JetBrains, which essentially means that I help developers use IntelliJ IDEA to work on their projects, which makes them more productive. I share the feedback from the developers with the product team at JetBrains, which completes the loop. I'm a Java champion and author of multiple books with Manning, O'Reilly, and Pact. I have been writing extensively on Oracle Java programmer certifications and why they help you to advance in your career. And in this webinar, I'll cover the new language features in Java 14 and 15, why you need those features, and how you can use it in your applications. So you probably know of developers who gave up working with Java because it was slow to evolve, but this is not the case anymore. Java 8 was released in March 2014. Back then, a new Java version was released in approximately 3 years. So Java 9 was released in September 2017, which was 3.5 years after Java 8. And Java's release cadence changed with Java 9. And Oracle committed to a new 6-month release cycle with a newer version of Java every March and September. So Java 10 was released in March 2018, 6 months after Java 9, Java 11 in September 2018, and so on. The latest Java version is Java 14, which was released in March this year. And Java 15 will be released in September this year. I believe most of you are already familiar with the release cadence, but I repeated that just in case if any one of you is not. So it would be good to know how the Java release cadence has changed, and that would help you to understand why we are having new releases in 6 months and how and why it is difficult to keep pace with what's new in Java. So just to get started, so I would appreciate if in the chat window you could write the version of Java you manage to use or play around with. So I'm not talking about the version that you are using in production, but any version that you manage to write just bits and pieces of code with. Okay, so let's get started with Java 14. For any new Java version that you have, how do you find out what's new? My go-to resources are, the first one is to check out the OpenJDK website. So when you access this link, you get to see the new features which are included as JEPs, which is the Java Enhancement Proposals. So these are the features you can see went in Java 14. And when you click on each of these features, you can find more detail about them. Are you wondering, are there no API changes? And if so, how you can access them? So this is one of my favorite links to find out how the API has changed. So let me show you this link. So this shows the differences from Java. So this is 12 to 13. So did I? So that was 14. Did I miss something? So this one says Java SC 13. So let me change it to 14. And probably I'm sorry, I probably missed changing the link in the presentation. So this is a list where you can see how Java 14 has changed from Java 13. The additions are in a green background, the changes are here, red text, and the removals are with a red background. Let's quickly go to one of the packages and see how, let's say, the string class has changed. Now, let me click it here, and I can see how this has changed. It says change 3. Am I using the right one? Because right before the presentation, I managed to see that it has changed. Okay, so let's go to another class, which is strict math. And this is how it says, these are the methods which have been added to this class. So this is how you can access the link and figure out how a specific Java version has changed from one version to another. So the new language features in Java 14 are records, pattern matching, for instance, of text blocks, and switch expressions, which I'll cover in this presentation. So let's get started with records. Records introduce a new type in Java. Let's see why you would need a new type in Java. Imagine you go to shopping for pants or trousers and see that all pants are of the same size. So depending on your size, they could be big, tight, or small for you. And if you're lucky enough, they might fit perfectly. But what happens if they don't fit you? You alter them. And this is what, as developers, we have been doing with the value object classes in Java. We use a Java class and then add the relevant code to it so that it works like a carrier of data. So let me go to the demonstration and show how this works. So let's assume that I want to store the details of person, and I want to store it to, let's say, a file, and then I want to retrieve it. So what are the steps? So the first one is that I create a class person. So let me say I want to create a class person. I say a Java class, and I name this class person. I create 2 fields. I say string name and private int age. So these are the 2 fields that I want to have in my class person. So what next? So as we all read, so if I have a class person, I define the fields as private, and then I define the other helper methods. I want a constructor, I want the getters and setters, I want other methods as toString, hashcode, and equals. And how do I do that? Okay, so let me just quickly generate this using my IDE. So I generate a constructor. And let me just collapse it so we don't really want to see what we don't require. So getters and setters. So I want to generate the getters and setters for my class. And now I generate equals and hashcode method. Okay, so this is done too. And now I want to generate this toString method. Now this one looks good too. So let's see, let me go back to my read write object class and try to figure out how I could do that. Let's say I say not string, I want to instantiate person, and I say person is, and then I say, okay, the name is Java, and I say the age is 25. Yes, Java is 25 this year. Now I just write this object to my file. Okay, I need to pass it a value, and the value is temp.txt, and then I say I want to read the value. I say read from file, and then I pass it the same path. Okay, so I also need to make the person class implement the serializable interface so that I can write the instances to the class. Now I am running this class. System cannot find the file specified this. Okay, right. So what I just did was I created a regular class. I generated a lot of helper methods, and then I used it to write it to a file and then retrieve the file. What if I don't want to do that? So let me go back and let me just delete these lines, and now let me go back to the person, and I don't want the person class as well. So let me delete this one. So I say delete. Okay. So now let me define the class person as a record. I say I want to create a record and I want to name it person. Okay, so let me redo that. I go to records and I say I want to create a Java class, and I select the type as record and I say person. I'm so used to using the auto completion. So the last time I tried to create a class, I said PERS, assuming that it would auto complete. I know that was stupid. So, so this is how you create a record. And the fields can go in here. I can say it has two fields, string name, and I have int age. So this is what I need to create a class person with the same functionality that we used in the last example, which was creating class person as a full-fledged class. So now let me go back to the read-write object class, and let's say I say person, and now see that I am creating this, I'm instantiating a record the way I instantiated a regular class using the new keyword, and I'm passing it the values. Okay, so I say Java again. So let me change the values. So just in case we know that we're not retrieving the same values. So now I write this object to again. So this was temp.txt, and I say now I have to read the values. I say read from file, and I have to say I have to pass in the values. So these are the values. The name of the file goes in. Oh my god, I feel so handicapped without the auto completion. Great. So now let me run it again. I'm not sure. Okay. Wow. So, okay. So it says, I cannot do that because the class, the record person is not serializable. So let me go back and let me say that it implements serializable interface. Now let's see how it works. Yes. So as you can see, I instantiated record person, and I save that to a file, and I retrieve the value from the file. So, and I missed one part. So I am using Java 15 because I would be demonstrating Java 14 and 15. So, and the other point is I'm using Java IntelliJ IDEA 2020.2. So there are two things. If you want to work with Java 14 and 15, you have to use Java 2020.1 and above for Java 14. And to use Java 15, you have to use IntelliJ IDEA 2020.2. And you have to configure your SDK or the JDK with either Java 14 or 15. And you have to select the language features that you want to work with. So I'm using the preview language features, all these from Java 15. So that's it for the configuration part. And just one thing, if you are using the latest version of IntelliJ IDEA, which is 2020.1, you can also download the JDK from within IntelliJ IDEA. So that should be the configuration part should be simple. Okay, so what else? Now, do you know that records, they give you a syntactic sugar? Because we initially created a class person and we added all the methods to it. But with records, I can use this one line and everything would still be generated by the compiler for us. And you can view that if you go to the compiled version and you check out the person class. So this is the decompiled code for the record that we just created. So as you can see, it has the setters, no setters, it only has getters because the fields are declared to be final. And there's a constructor, you have this toString, hash codes, and equals method. Now, what else can we see about records? We already had a look at how to instantiate. Now, there's another thing. What else can you define in a record? I cannot define another field in a record because I would like my record to be represented by the fields I define it in the definition here. So if I say, let's say string address, this is not allowed. It says instance field is not allowed in record. But of course, I can say, I can define static values in a record. This is allowed. And again, I could add instance methods to a record and static method. I could say string static get address, and I could say return address and static, what am I doing wrong? Static string get address. Okay, so this is, you can define a static method and you can also define an instance method. I could, let's say, string get a value, and I could say return. This is, I'm defining a instance method in a record, and this is acceptable too. What else can I do? I can also define a generic record. So let me create another class, and I choose Java class, and then I say it's a record, and the name of my record is, let's say, parcel. And I can say public record parcel. I pass in a generic parameter, and then I say the contents, and I could say double weight. So this is my record, which is a generic record. So let me define, let's say, another class, which I say a table. So this is just to show you how to instantiate the class parcel. So let me define a main method here, and I can instantiate the generic record parcel by saying, okay, so parcel table parcel is equal to new parcel, and I say new table, and let's say the weight is 200 point. So this is how I can create a record with generics, and this is how I can instantiate one. And I could also add annotations here. I can say this is not null. Why do I always get the errors doing that? Okay, so let me do that again. Okay. I'm adding the annotation not null to one of the fields for the record. And other interesting point is, if I go back to the read-write object class, when, okay, so there's another thing which, let me go back to the person class, person record. I can define, let me just kind of get rid of these. And so by default, I get a constructor for my record, but I can also define another constructor, which let's say I say constructor, I say compact constructor, and I say if age is less than 0, I want to throw an illegal argument exception. So age can't be less than 0. So when I do that, I, of course, this would call the default constructor, which would assign the value to the fields, but it would be required if I say, if I want to validate some values which I pass to the constructor. And the other interesting part is, if you construct your objects from a file, the constructors for regular classes are not called, but if you do that with the records, the constructors would be called. And in this case, if the value which was written to the file, it violates the value, let's say the age for class for record person, then you would get an error here. All right, so now let me move to the other new language feature, which is the pattern matching for instance of. So many of us developers, we use instance of operator to check whether a given reference type is of a certain type. So let me go back to the demo, and let's. Okay, so this is how we usually use the instance of operator. So let's say I'm talking about a method output value in uppercase, and the object passed here is I'm assuming or I'm expecting a type of string to be passed to this method. What would I do? I would say if object instance of class string, then what do I want to do? I want to create a variable again. Let's say this is a value, and I would cast the object to type string, right? and then probably I want to output the value of this variable. So this is generally how we do. We compare the type of a variable to, we compare a variable to a type, and then we cast it to the same type, and then we use the value. This is, of course, as you see, is repetition. So what happens with Java 14, I could replace this variable with a pattern variable. In other terms, I can absolutely not have this line of code. Let's see what happens. So now this variable, a value, has been added as a pattern variable here. So when object instance of string evaluates to true, a value would be populated with the right type. So I don't really have to do the casting. And this is how it would look. Just in case if you think it is too simple to get a lot of attention, think again. Let me take you to another method. So this is probably you have seen or written code like this where you are trying to determine whether two values are equals using the equals method. So this looks not so long method, but let me use pattern matching for instance of here, and let me replace this local variable with pattern variable. I could do that by using Alt Enter in IntelliJ IDEA, which would give me the suggestions depending on the context I am. So it says replace other with a pattern variable, which I do. This is perfect. And I could also use Alt Enter to merge these ifs. So there are two ifs, as you can see. I can merge these. And this is how it has become now. How do I turn this one as well? This is insane. Simplify, yes. So now, so if you want, I could go back to the method that we started with, and this is how it has become. So this is what we started with, and we had just a single line of code. Right. Okay, so I would never get it again. Now, let me go to the other example. Now, in this case, so what happens when I talk about the if part? So this is the pattern variable here, and I can use this pattern variable in the then part of the if construct. But the same variable would not be available in the else part. But what happens if your class has a variable with the same name as the pattern variable? So you can compare that with the local variables and the instance variables or the class variables that you have in a class. So in a method, you could refer to a local variable and an instance variable. So the same logic applies to the pattern variables also. In this case, this S doesn't refer to the pattern variable S, which is defined here. It refers to the field S, which is defined here. Now, let me show you another example. So this is another example, let's say, which has 7 to 8 lines of code. Let's see how if I replace letter node with a pattern variable, how can that help me to make this code concise? So let me first merge these if statements. Now I am replacing letter node with a pattern variable. Now this gives me the opportunity to again merge the nested ifs. Now IntelliJ IDEA has, if you see, IntelliJ IDEA just highlighted this line of code, and I could use Alt and Enter to see the suggestions. It says I could replace the loop here, and now I could inline this variable as well. So now see the difference. Now what I have here is a concise method. Now you can compare it to the 7 or 8 lines of code that I had in the previous version. So it's not about having a change like instance of pattern matching for instance of, which you think might be quite small. It would be how you use that in your code. That really makes a lot of difference, because since it's a language feature, it would be interacting with the all other parts of the Java language. And when you have a combination of those features, you can, of course, make a lot of changes. So what do I have here? Probably another example. I already covered this part. So let me go back to the text blocks. This is one of my favorites. So what happens with the text blocks? Okay, so we have a demo. I was hoping I have a picture, but I don't. Okay. So text blocks are another type of string type, not another type. So the compiler gives us the syntactic sugar to work with the string types, which are difficult to work with the as they were until now. So let's say, okay, so let me compare the strings to little children. So what happens when the children are small? They are cute, but what happens as they grow old? We all know that, probably not all of you who don't have children, but let me start with the, let's say, a simple example, a small string. Okay, so I say, hello, I am a small kid. This looks cute, isn't it? A small string with is quite simple to read, and we don't seem to have any problem here. Let's see what happens when it grows bigger. Okay, so it says, like a kid, now I can crawl. And what happens? I can now fall off my crib, and I can now throw a lot of tantrums. The ones who have kids would understand this part. So let's see what happens. So this is now, the kid is now, I am a teen now. Yeah, and now I want to learn a lot of new languages. So let's say, which language can this kid learn? So let me go to my other file, and let's say if this kid can learn JSON. Wow, this looks nice and complicated. Let's say if the kid plans to learn SQL as well, right? Wow. Now, do you understand the problem with the longer strings? The strings are okay when they are small, but as they grow in size, it is difficult to edit them, to read them, and to write them. Of course, I was using the help of IntelliJ IDEA to write a complicated string like this. But if I try to kind of write a JSON by myself, it would be difficult, because you really have to think, when would you need the double quotes first or the backslash first? That is a nightmare. So what can we do with the text blocks? I can define, I can say this is a longer string, and I, instead of a single double quote, I would use 3 double quotes. And now let me add my longer query, or let's say I could just copy paste the SQL statement which I saved from the other text file. So this is how it would look. And if I say a string, and this is how a regular string would look. Can you see the difference here? This is simple to use and understand, but this one is bit complicated. And as I mentioned, as it grows in size, it becomes more complicated. So this is what text blocks are trying to help you with. Now, what happens to, okay, so these are the delimiters that you use with text blocks, and a single double quote is the delimiter that you have been used to using with the regular strings. And as I mentioned before, Java is not adding a new data type to the language. You still are using the same string. It's just the syntactic sugar so that it makes your life easier. So that really means that you can use all the methods and the fields which are available to your regular strings. And so what happens to the delimiters? So, and yes, when you start a text block, you have to start, the value should start on the next line. So I need to have a new line here. If I try to delete that, I would get an error, which is, see, illegal text block start, missing new line after opening quotes. So I need to define it like this. Now, what happens are these spaces, the ones which start from here to here, are these part of the value? No, they are not. So we're talking about what happens to the incidental white spaces in a text block. If you can see, if you can notice a green vertical line here, this is the line which you can use in IntelliJ IDEA to see which values or which spaces would be included in your text blocks. If I move this here, now these are the spaces which would be included in the text block. So how it is calculated is all the white spaces which are before this line of code, those are ignored. And you can also use the closing delimiter to specify how many spaces you want in your text block. So this is how you can move your values around. And by default, you have a new line until Java 13. The line was included. Now, of course, you can use backslash to not include a space at the end of the line. And of course, you can use another delimiter, not delimiter. I'm missing the exact combination which can be used if you don't want a new line at the end of all the lines. Right. And the other part is what happens if you probably are not able to use, let's say, the latest Java version. So let me have another string, and I could say string, and this is JSON, and I am adding this value here. Now, this JSON value has an error because I should be having a comma at the end of the value here. What I can do is I could inject language, and I could say this is JSON, and now it gives me this error. This is highlighted by the orange line, and now I could use the right indentation, not the indentation, the right syntax. So I get code completion, syntax highlighting if I inject the language or the reference in a string. And this applies to both your regular strings and your text blocks. So, and as I mentioned earlier, because it's a string, I could concatenate values. So let's say I have first name is, let's say, Mala, and I say, okay, this is Gupta, and I can concatenate the values like this. So all the methods which are available in string are, you can use that with text blocks as well. Now going to the switch expressions, this is again one of my favorites. So let's say how, I don't think, yes, demo again. Let me open the project window, and let's say if I have any code. Not really. Oh, yes, I do. But okay. Should I be deleting that one? Okay, let me delete that one. Or should I use it because we're running out of time? Okay. So this is a class planner, and I have an enum, which is a single-use plastics. So what happens if I want to, let's say, I want to define a method which returns a value, and I pass this method single-use plastic, right? So I define a variable, and I say damage is 0, then I say return right. Now, what have we been doing with our regular switch expressions? We pass it a value, and then we match it with an instance or the value of the enum, and then we assign a value to the variable. Let's say if you use a bottle as a single-use plastic item, you do a damage of, let's say, 10 points. Then you say cup, you say damage is, let's say, 20, and you have a break statement, and then you have fork, and the damage is, let's say, 29. Again, a break statement. The last one is plate, and you again assign a value to the variable damage. You say it's, let's say, 12. So what is the problem with this line of code? The problem is that it has the obvious repetition of the break statements here. What happens if you do not, you miss adding the break statement here? In this case, when the value bottle is passed to this method, instead of assigning the value as 10, it would assign the value as 20, because without a break statement, the control would fall through the next case label. This is one of the problems which the switch expressions is trying to address. When I talk about switch expressions, I'm talking about an expression which can return a value. And in this case, what we're trying to do is we're trying to use a switch statement, but we are actually assigning a value to a variable which we want to return. So switch expressions is a modified form of switch statement which is trying to address both of these issues. So let me change this to switch expression, and this is how it would look. Now let's see if there is another issue that it can take care of. Yes. Let's see what the suggestions are. Or if I have the same code to execute for multiple case labels, I can define multiple labels in the same switch case label. And in this case, default is redundant because I have addressed all the values for this enum. But what happens if the data type that I'm passing to a switch expression is of type string or int or short byte, which do not have exhaustive list of values? In that case, I would need a default value because those types would not have an exhaustive list of values. And when I'm saying switch expression must return a value, then of course I should be returning a value. And instead of returning just a value, I could also define a code of block here. I could define, let's say, int age is equal to 10, and then I could use the yield keyword to return a value. This is how I can return value by defining code of block in the switch statement. Right. So this was switch expressions. So now, and of course, I covered the essentials. If you want to deep dive on all these 4 topics, you can access this link and view the blog post and the screencast, which covers all these features in detail. So I was mentioning that these features are preview language feature. No, switch expressions is a standard language feature in Java 14, but records and pattern matching, for instance, of are preview language features. These are the features which are complete but not permanent in the Java language. And what does that mean? That means that Oracle is looking for feedback from the developers on the new features that they are adding to the language. Oracle wants to make sure that any feature that goes into the language is safe enough and usable, because once a language feature is made permanent, unlike an API, it cannot be rolled back or deprecated. So I specifically asked Brian, is there a deadline for submitting the feedback? So he mentioned there's no deadline, but the sooner the better. Right. So the text blocks is in second preview. So as you go through the new features in Java language now, you would see whether it's the first preview, the second preview, or it's a standard feature now. So that's again an Oracle's way of ensuring and making changes to the language features before they go in as a permanent or a standard language feature. Now, let's come to Java 15, just 6 minutes left. I'll quickly browse through 2 of the Java language features which have been added or modified in Java 15. Again, how to find what's new? My go-to resources are the page on OpenJDK. So this is the URL that you can use. And again, you can use the similar link to find out how Java 15 has changed from Java 14. Of course, there are a lot of other resources that you can refer to, but these 2 resources are from Oracle, and these are my go-to resources to access the changes in a particular Java version. So the new language features in Java 15. So one of them is sealed classes. And what does that mean? When I talk about sealed classes, so that's another way of constraining. So we talk about modules, packages, encapsulations. What are they? They are a way to restrict access to who can access your classes or interfaces. Sealed classes is another way to do that. So let me go and Java 15, let me create another class in this. And let me name the class as, let's say, shape. This is a class. And how do I define this as a sealed class? I can use the keyword sealed to define this as a sealed class. Now, shape is a sealed class. Now, what is the error message? Okay, so every sealed class must have a subtype. So let me create a subclass, and let me say the subclass of square is shape. Okay, so it already has, now let me say circle. Right. Now, what the problem is now. So circle is not allowed in the sealed hierarchy. So we've just seen 2 points. If I define a class as a sealed type, then it must have certain implementations. But and it goes the other way around as well. When I define an implementation of a sealed type, that must be defined in the hierarchy of the sealed type. So let me go back to the shape class, and here I say permits and I say circle. Now, is it okay now? No, still not okay. Okay, so it says the implementation of a sealed class should be final. Okay, so I say public final class circle extends. So we just created a sealed class, which is shape, which permits it to be extended by class circle. And class circle mentions that it is a final class and it extends the class shape. So this is what sealed types are in Java 15. As I mentioned, they provide another way of defining who can access your class and who can extend it, who can extend your class basically. So let's go to the records, which is in the second preview in Java 15. So there are a couple of modifications to how records are in Java 15 if we compare them to what records were in Java 14. So let me go back to the demo. So Java 15 records, do we have the demo? No, we don't. Okay, yes, we do. Okay, so I think we're running out of time, so I cannot type it out. So the modifications with records in Java 15 is that now you can define records as local types within a method, which was not allowed in Java 14. And why only limit that to records? With Java 15, you can also define your interfaces as you can define local interfaces. You can also define local enums. So these are the changes which have come in with records in Java 15. So of course, as I mentioned, preview language features, I've already covered that. IntelliJ IDEA configuration, I always miss this part, so that's the reason why I added this as a slide. You have to select the preview language features from the language settings in IntelliJ IDEA if you want to use the language features. Preview language, sorry. So thank you so much. Thank you everyone for listening to the session, and I am open for questions if you have.
Oh, yes. Thank you, Mala, very much. And we are going to start with the questions. Recordarles a todos que pueden postear sus preguntas. And, well, I have here a question from Mateo. When Project Loom fibers will be released?
Okay, so we don't have a date for the release of Project Loom, but the early access version of Project Loom is available, and you can download the JDK with the Project Loom, and you can try out those examples now. So it is not released as part of JDK 15, and as I said, I don't know when that would be released because Oracle doesn't attach a release date to any of the features or the projects until they are complete and they are ready to go. But yes, you can download it, the early version, and try it out now. It's amazing. It's amazing. You should do that.
Okay, next question. Can we compare the Java records with the Pojo? Plain old Java object, are they the same?
Absolutely, because the Java records are here to kind of take away the pain points which the Pojos had, because when you were writing Pojos, even though you needed only those 2 lines of code where you were defining your fields, you had to define all the supporting methods, because as you know, if you don't define the hash codes or equals method, you will not be able to kind of add those Pojos to your collection classes, add keys. So this is the pain point which records are taking away. So of course, feel free to use records in place of the Pojos.
Okay, thank you. Next question from Mateo. Hello, Mala. Greetings from Bolivia. Are you using Java 13, 14, or 15 in production environments?
I didn't get the question. So he is asking me, am I using or should he be using?
which one are you using, 13, 14, or 15 in production environments?
Okay, so usually, so for my demos, I use the latest version because, as I mentioned, because I was demoing the features of Java 14 and 15, so I was using them in the demo. But if I go to the production code, we at JetBrains, we are not using 14 or 15 because a lot of features which are defined as the preview language features, they might change in the next version. So the best advice would be to use the LTS version, which would be Java 11 as of now for production code. Of course, I would highly recommend that you try out all the new language features, but for production, it is much safer to be on the long-term support releases, or at least the version which has the standard features and not preview language features. I know it's an irony that Oracle expects the developers to send the feedback on the real code, but yes, of course, we know that there are some negatives, downsides to that as well.
Okay, well, there are some comments like Java 8. I think most of people is using Java 8.
Right.
And
Right. So
another
that,
question?
so that is the answer to the question which I asked initially during the. Oh, great. Yes, I can understand a lot of people are still on Java 8. But so my question was more about, so which is the version that you got to kind of use with any code? So that is okay.
Okay. Thank you. There is another question from Omar Rivera. Are the records immutables?
They are shallowly immutable. What that means is if I have, so when I showed the decompiled version of the records, you could see that the fields were defined as final. So I cannot assign a final field to another variable. But of course, if I'm talking about an object which is defined as a field, I could modify or alter the value of that field. So that is what it means by immutable, but shallowly immutable. So it's a shallow immutability that we're talking about.
Okay, thank you. And the last question from Yomara. What do you think that comes from Java in later versions?
I didn't get the question. So the question is asking me what am I expecting to see in the later version of Java?
Yes, I guess so.
I guess Brian would be a better person to answer that question. So he's the language architect at Oracle. But of course, I understand that, yes, it is an interesting point to kind of get to know what's happening at Oracle and what new features can we see. So I would recommend the person who asked the question to kind of follow Project Amber at Oracle, which talks about the latest language features that are in works, and they would be added to the language as and when they are complete. So Project Amber is the one to watch out for, and you would get lots of interesting information on the mailing list there.
Thank you very much. It has been a pleasure having you with us and teaching us all that features that will make our life easier. And it's been an honor having you here, and I hope this is not the last time you are sharing with the Bolivian Java community.
Thank you so much. It was a pleasure to share my presentation today, and of course, not the last time. I would love to be invited again, and I would be good to present again. Thank you so much, and all the best to all of you.
Thank you, Mala.
Bye.
Goodbye. Gracias a todos por su participación, por las preguntas y bueno, vamos a ir con nuestra siguiente charla y la última. Y tengo el grato placer de presentar a Grace Jensen, developer representante de la compañía internacional IBM. Hi, Grace. Are you there?
Hi. Yeah, I'm here. Let's see if I get
Hi,
my video
Grace.
working. Hey, how you doing?
It's a pleasure having you with us.
Thanks for having me.
Go on.
So would you like me just to start?
Yes, you can start your presentation.
Yeah, fabulous. Okay, let's see if I can. I'll just do my entire screen. Oh, okay, I just need to allow all my preferences. There we go. Can you see my screen?
It's loading.
Great.
Yes.
Yep, so you can see yourselves? Yeah. Great, okay,
Yes.
Inception there. Okay. And let's get this running. Great. You can see that fine?
Yes.
Fantastic. Okay, cool. Thank you for having me. Yeah, so as you probably already introduced in Spanish, which I'm really sorry I speak very little of, my name is Grace Jansen, and I'm a developer advocate at IBM. I work in the UK, if you couldn't guess from my accent. And I've been working in IBM for about 2.5 years now. Been a developer advocate there pretty much the whole time. I specialize in reactive sort of technologies in the Java and JVM ecosystems. So today I'm going to hopefully take you through sort of what reactive really means, and relate it to some fun kind of analogies to hopefully make it a bit simpler and easier to sort of get your head around and hopefully remember. So without further ado, we'll get started with my presentation, reacting to the future of application architecture. So to look forward to the future of application architecture, we first have to look at sort of where we've evolved with our application architecture so far. So we started off with these sort of monolithic applications where monolithic at the time was fine because our applications were fairly small. They didn't have to deal with that much data. We didn't have that much network traffic coming in. So having this application all as one big chunk made a lot of sense. But as our applications grew and grew and grew, and the amount of data they had to handle increased, the amount of network traffic increased, we made this move from monolithic architecture to microservice architecture. And this helped to solve a lot of the issues that we were previously facing. So things like being able to roll out new features without having to bring the entire application down, or even trying to find bugs within our application became a lot easier. Being able to scale out and scale back down again, for example, being able to distribute on a cloud infrastructure. All of these things became a lot easier when we switched to microservices. But there's still issues with microservices that this architecture alone doesn't necessarily solve that many applications still face today. Like, for example, on Black Friday, I can go to a shopping website and I can find that suddenly the whole application and the whole website has crashed because of a huge influx of traffic and network volume. I can still go and try and reserve seats for the cinema or the theatre and find that halfway through trying to reserve those seats and complete my booking, suddenly those seats are unavailable anymore. So there's still sort of issues and kinks and problems that we face with this microservice architecture that society nowadays expects more from. As a user of the internet and as a user of basically with the choice of hundreds of different applications, I expect the applications that I choose to use as a user to work no matter the day, no matter the time of day, no matter who else is trying to access the site. And I expect to have the same user experience every time I log onto that website or try and use that application. So how can we solve these issues and sort of meet the demands of modern users today? So I come from a sort of unusual background in software and sort of in the developer world, and I did a biology degree at university. So I like to link anything I learn in software and through my developer job to biological analogies that I know of and can understand in the natural world. So when I saw microservices, to me, it made a great connection to bees and beehives. So just like microservices, each bee, like each microservice, has its own individual role or responsibility. But together, they work as one for the benefit of the hive, just like microservices work together to perform the function of the application or the system. So I saw this great link between the two. And it's amazing because bees have had literally millennia. The oldest bee fossil is 100 million years old. So they've had 100 million years to evolve and improve and become as efficient as possible as a unit. And I think that there's a lot of behaviors that we see in bees that they've evolved over this time that we want to see in our own applications. And that actually links really well to application techniques and patterns and I guess patterns is the best word, patterns that we use or have been engineered within software engineering. So I'm going to take you through 3 of those behaviors and link them to sort of the software and where reactive comes into this all. So the first of those behaviors is food foraging. So beehives are this incredibly complex structure where each individual bee has their own responsibility and their own role within the hive. So you can be a forager bee, you can be a scout bee, you can be an undertaker bee, you can be an air conditioning bee, a nurser bee. There are hundreds of different roles within the hive itself. Now, one of those roles is actually the scout bee. Now, the scout bee's role is to basically go out of the hive and find food, so find flowers for them to collect the pollen for them to produce the honey. So when a scout goes out and finds a flower, it immediately rushes back to the hive and it makes its way to these dedicated dance floors. Now, when it gets to these dedicated dance floors, there's usually a bunch of sort of active listener bees around the dance floor that are waiting ready for a signal from a scout bee. So when the scout bee arrives at the dance floor, it starts basically dancing around to communicate to the other listener bees where that flower is and how to get there. It can communicate a huge array of information, including things like how far away the flower is, how rich the food source is, how many bees should go there, how efficient it is to get there. So they can communicate this huge amount of information. And they do that by basically wiggling around their bottoms in different directions and dancing. Now, as soon as these listener bees around the outside of the dance floor get the minimum amount of information they need, they immediately rush off to that food source. And that's really important. Excuse me. So it's really important that these bees react as soon as possible to the minimum amount of information they need. And that's because in this case for bees, it is quite literally a life or death situation. If these listener bees don't get to the flower in time, a neighboring hive, for example, could come along, reach that flower quicker and drain that flower of the food that they desperately need. So it's really important that they're as responsive as possible to these scout bees and the minimum instructions that they need. So this is what we want to see in our applications. We want our applications to be as responsive as possible to the state changes that we receive and the data and the events we receive as a system. We want them to be able to respond as soon as a user clicks on some actionable button, for example, or as soon as a piece of information comes in that we need to propagate forward to the front end. We need to be able to be as responsive to these events as possible. So we want to mimic this behavior. Now, the second behavior is what happens in the potentially catastrophic situation that one of the most important components of a system fails. So, in a beehive, arguably the most important person within that beehive is the queen. There is only ever one queen, and the queen's whole role is to basically produce the new baby bees to keep the hive going. So if there's no queen, there's no baby bees, no future hive. So the queen is arguably the most important person. So what happens in the potentially catastrophic situation that she dies? Well, if she dies, what happens is while she's alive, she produces these pheromone or these chemical signals. And the bees, the nurser bees around her are able to detect this and know that all's well. But if she dies, those chemical signals disappear. And so the nurser bees around her that usually look after her then kick into action and they know that they have to now produce a new queen bee to replace her. So what they do is they grab 4 or 5 larvae that haven't hatched yet and they start feeding them royal jelly. And now this royal jelly turns them into queens. So the first of those larvae to hatch becomes the new queen. So instead of the software going down, instead of the system crashing, instead of the beehives, the other bees who also notice when the chemical signal is gone, stopping doing their daily roles because they think, oh, the queen's gone, there is no future to this hive. No, they carry on because they know that they have this intrinsic trust that they know that the hive as a whole will replace this important component, the queen bee. And this resiliency is something that we want to mimic in our own applications. if a very important microservice goes down or a component of your application, we don't want your entire application crashing or basically becoming unresponsive. What we want is to be able to build in resiliency in the face of any potential failure. And so we want to mimic the resiliency that bees show. So the third behavior, what happens when bees go to war? I got a little bit dramatic with this one. But essentially what happens when the beehive is under greater load than they usually have to deal with? So as I mentioned, there's loads of different roles within the hive. And one of the roles that bees can play is a guard bee. Now, the guard bee, as the name sort of suggests, is the type of bee that protects the hive from sort of competing hives or competing bees or predators. So what happens when something that's bigger than this worm, for example, comes along and tries to attack the hive? So let's imagine we've got a massive grizzly bear trying to access the honey in the hive, coming at this beehive. So at any one time, there's normally only about 11% of the hive population are guard bees. Now, when you think of how small a bee is, 11% of a hive, which isn't that many bees, probably isn't going to deter a massive grizzly bear away from the hive. So what the bees have to do is respond to this increased load. And they do that by the guard bees basically go back into the hive and actually actively recruit more bees to be able to switch roles dynamically and become guard bees. So whether they're nurser bees or undertaker bees or air conditioning bees, they're able to switch roles elastically and dynamically and become guard bees to be able to deal with this increased load on the system, this bear. Once the bear's gone and it's been deterred away from the hive, they can then switch back to the roles that they were previously doing before. So bees have this incredible ability to elastically switch roles and basically elastically change their resource allocation depending on the differing loads and increased or decreased loads to the system. We want to be able to mimic this in our own applications again. So if we have microservices and I've got a restaurant application and I've got loads of people trying to book a table, but hardly anyone at the moment trying to pay, then I want to be able to elastically scale the microservices or the resources allocated to the book a table service within my application, and maybe to be cost efficient, scale away from the one where I allocated to payments. So being able to elastically scale resources within our application enables us to better deal with these increased loads or changing loads, fluctuating loads, in a cost-effective manner. So as I said, I did promise this isn't just a rant about bees, although I do love them. This does relate to software. So each of the behaviors I mentioned links really well to the different cornerstones of the Reactive Manifesto. So back in 2013, the Reactive Manifesto was created, and it's essentially a specification that lists out the key behaviors and characteristics that you should be sort of designing and building into your applications in order to make them as reactive as possible. And it's made out of 4 key cornerstones. So the first of those cornerstones links to the first behavior I showed you. So it's about being responsive. So just like the bees have to respond as soon as possible to those scout bees telling them where the food is, we want our applications to be as responsive to state changes or events within the application as possible, so that we can then propagate those responses to the user and have a very reactive interface for our application. Now, in order to achieve that responsiveness, we need to have 2 other characteristics. Now, the first of those relates to the last behavior I told you about. So being able to elastically change our resource allocation enables us to gracefully deal with load, which means that even if we're suddenly flooded with lots of network requests or users trying to access our application is able to gracefully deal with those load changes so that we don't get clogged or we don't fail or our system doesn't go down, and we're still able to respond and be responsive so that we can be reactive. And the second characteristic that enables this behavior is resiliency. Just like I showed you with the bees are resilient in the face of the failure where the queen dies. We need to build in that resiliency as well. As software developers, we cannot, as much as we try, we cannot predict every potential failure within our application. It's just not possible because new failures come up all the time. So what we need to do is build into our application inbuilt resiliency so that if a potential failure happens, we know that our application will be able to sort of deal with that failure gracefully and the rest of the application can continue on as best as possible whilst we try and fix that bug or bring back up that microservice or that component of our application. And so elasticity and resiliency really allow us to gracefully deal with potential failures or load fluctuations to enable this increased responsiveness. And now all of these three characteristics are underpinned by one key characteristic, which is also the same characteristic for all of the behaviors that I showed you with the beehive. And if you can't tell from my drawing, it's actually being message-driven. So having this asynchronous message-driven backbone, which enables us to sort of decouple away the different components of our application. So with the bees are able to communicate both on a one-to-one basis, but also on a one-to-many basis to multiple bees without having to synchronously wait for each bee to respond. So when the scout bees are dancing, they don't wait to see if each bee has gotten the information they need. They just broadcast the information and know that those who need to listen will be listening and will act accordingly to the information they're given. And we need to have the same sort of system in our applications. We need to have this asynchronicity so that we can decouple the components of our application so that we can be more responsive and we have less blocking and bottlenecks within our systems. So these are the 4 key characteristics of the reactive manifesto. And it seems to map really well to the issues that we were sort of facing when it came to microservices and where we want our application architecture to be heading in terms of its future evolution. So maybe reactive architecture is something we should be considering when we're looking at evolving our own applications and how we can improve the user experience that we give to our clients and our customers. So this is all well and good, but everything I've mentioned so far has been fairly theoretical. So how do we actually build reactive systems? So let's take a look at a fairly basic system here. We've only got 3 microservices, but just to show you sort of the different levels that we need to be thinking about when we're building reactive systems. So the first of those levels is so we're starting from sort of the top down. So the first of those levels is, okay, how do I build in asynchronicity and non-blocking, so essentially the reactive nature, into the interactions between the components of my applications. So that might be between components, so between microservices within my application, or it might be between a microservice in my application and a third party. So maybe a third party database, or for example, someone else's application, or another team's application from my company. So having to, how do we integrate these components together in a reactive and non-blocking manner? This is where reactive architecture patterns come into play. And we'll come back to those a bit more in a minute. Let's take a look at sort of one level down from that. As well as thinking about how our components interact with each other, we also have to build our components to be reactive in themselves. So we need to build our microservices so that they have non-blocking programming within them. And we can do this using reactive programming patterns. So that includes futures, which you can get in standard Java. It also includes using things like the reactive stream specification and things like reactive programming libraries, like, for example, RxJava. So by using these reactive programming patterns, we can build in asynchronicity and that non-blocking nature into the individual microservices and use the reactive architecture patterns for the in-between the microservices and the other components. So what is reactive programming? As I sort of mentioned, it's essentially a way of designing in asynchronous programming into your microservices. So it's driving forward the logic of your microservice using the availability of new information instead of using this thread of execution techniques that's sort of more traditional. And we can achieve that by using the programming patterns I mentioned earlier. So using futures. You may have come across futures before if you've been using Java for a while. So a future is essentially a promise to hold the result of some operation until that operation completes. So it really enables this sort of asynchronous request to other microservices and other components within your application. So then we've got reactive programming libraries. So as I said, there are a couple like RxJava or Small Mutiny, and they enable more asynchronous event-based programs. And then you've got this thing called reactive streams, which will come into a bit more detail later, but it's essentially a specification about, it's all about having this programming concept for handling asynchronous data streams whilst allowing back pressure to also happen, which is really important in our applications if we really want to achieve sort of this elastic and resilient nature. So what's the difference between the two components I've talked about? What's the difference between just implementing reactive programming or implementing reactive programming alongside things like reactive architecture patterns? So really making a reactive system as a whole. Well, if we go back to our bee example, this time we're going to imagine a bee football team, or soccer as you might know. So if we take a look at our bee football team, let's take a look at the one on the left. So on the left, we've got the reactive programming football team. Now, individually, they are the best scorers. They might be the best tacklers. They might be the best dribblers up the field, but they've never played together as a team. So when it actually comes to playing a game, they don't know how to respond or react to the other players on the pitch. They hold the ball, they don't pass it. When they do pass it, they're in the wrong place. As a system, as a team, as a whole, they're not particularly reactive, even though each individual player might be. Now, what if we took those players and instead of just shoving them together when they've never played together before, what if we trained them together for years and years and years, and we taught them how to do set plays, and we taught them how to respond to the behaviors of the other teammates on that team? This is where reactive systems comes into play. Reactive programming is a fantastic tool to be able to make the individual components of your application more reactive and non-blocking. But you have to also think about additional layers, like we've mentioned, where you use things like reactive architecture patterns so that your system as a whole can also be reactive, so that you can have better reactive and non-blocking behavior between those components as well as within them. So how do we achieve this reactive behavior? That is my one and only pun, and it had to happen. So let's take a look at some of the patterns that we can use when it comes to things like the reactive architecture patterns that I was talking about at the system level. So a common one that's often used when we're building reactive systems is event sourcing, or CQRS, or even both together. So event sourcing essentially is when you store the event changes or the state changes as a sequence of events, often in an immutable log. So sort of similar to something that you'd have with Kafka. And it can be used in sort of combination with CQRS. So CQRS is command query responsibility segregation, and it's essentially disassociating, so breaking up the read and the write APIs or the queries. So that enables us to have high availability of our information. And by using them on top of each other, it basically means you're persisting each event on the right part of the application, because you're splitting it with that CQRS technique, and using and applying event sourcing on top of it enables you to persist those events in that immutable log. So bees actually already do this. So if we take the example of the scout bee who was telling them where to find food, the scout bee, you can imagine, is the write API, and the listener bees each have a brain, and in their brains, they have a read API or a read query or a read database. So essentially what it means is the scout bee is able to write the information to the read bees, the listener bees, and that means that those listener bees can access that information whenever they need it, which is really helpful if, for example, they're flying towards the flower and a gust of wind comes along and it knocks them off course. They can then revisit the information in their head to find out where that flower is, with that high availability of that information that you get from CQRS, to be able to find out, oh, I just need to go left a bit and I'll reach the flower. So they can redirect themselves back to the flower because they have that immediate and high availability of that information by splitting these up. So that's one technique that's often used. Another pattern that's often used, if you aren't able to use something like an event log, for example, or a data stream, is sharding. So if you have to use something like a more traditional database, sharding can be a really great pattern to use to be able to increase the availability of that database and the information within it. So sharding essentially means separating out very large databases into smaller, faster, more manageable pieces. Each of those pieces we call a data shard. So shard just means a small part of a whole. So the idea of this is to basically make very large databases more manageable, and it enables greater parallelism without collisions of requests trying to access the same data, for example. So again, bees, amazing as they are, already do this. So bees, essentially, if you imagine the beehive, now bees don't have a massive vat of honey that they have to dump all the honey into. they actually have a really clever system of having a honeycomb structure. And what this means is instead of having this huge queue of bees having to wait because they can only pour honey in one at a time to the great big vat, instead what they can do is each bee can visit an individual cell within the honeycomb to fill in their honey and get rid of it. So that means that more bees are able to get rid of their sort of data, as you call it, or in this case, honey, into the individual compartments without colliding with other bees and without having this queue of sort of wasted resources within the application or within the system. So we want to achieve the same thing, and we can do that using techniques like sharding. Now, another tool or another pattern that's commonly used that I mentioned earlier that things like the reactive stream specification helps with is back pressure. Now, back pressure is a form of feedback from these subscribers to data to the publishers. So let's imagine in bees, we've got a queue of bees trying to dump their honey, but the bees who build the honey cells can't keep up with demand. So they haven't built enough cells for the bees to dump their honey into. Now, instead of just letting this huge queue form of very angry bees who can't dump their honey, what they could do instead is provide some feedback back to the producers, so back to the publishers of that honey, so to the bees who are collecting the honey and trying to dump it, saying, hey, guys, really sorry, we can't keep up with demand. Can you just give us a minute? Can you pause for a little minute? Or maybe could you assign some resources to us so that we can build some more cells and get this queue gone and become more efficient? So this form of feedback control helps subscribers to data and to information become less less overwhelmed or less prone to sort of becoming unresponsive because of massive requests that they can't deal with. And so by providing this feedback, they can sort of slow down the rate at which they're receiving data so that they can recover or complete any requests or any processes they're currently performing, so that risk of having a bottleneck or having a potential point of failure decreases. So this is a really important form of feedback that we can sort of implement and design into our applications to prevent those potential bottlenecks and that potential point of failure. And the last pattern I was going to talk about is circuit breaking. So circuit breaking, the bee example I'm going to show you is slightly different to the software, just because bees are intelligent beings. They have a brain, they can think for themselves, and as of yet, microservices generally don't. So in the case of bees, when a bee gets sick, it's able to recognize that it's not performing as it should be. It's not performing as well. And to prevent the risk of infection spreading to the rest of the hive, and also to prevent itself getting overwhelmed from trying to do its daily tasks while ill, just like us, it decides to take a break. So it goes on sick leave. So it basically leaves the hive and gives itself time to recover from that illness. Now, what that means is it means that the rest of the hive can continue on as normal, and any requests that are made that involve that particular bee type can be rerouted to other bees who do the same role. And we want to see this in our applications as well. So in our applications, we can use circuit breaking to stop microservices that are getting overwhelmed from becoming a bottleneck or a potential point of failure, sort of similar to the back pressure that I mentioned. So with circuit breaking, it actually generally tends to be things like the parent microservices or parent actors, depending on which type of architecture you're using. And it's the parent actors that recognize that there's the same error coming from the same microservice. And it can implement circuit breaking to give that microservice a chance to get better or to complete the processes it's trying to complete. And instead, what it does is it reroutes any requests to duplicate microservices who can do the same processing or the same task. And what that means is our microservice is able to get better. And once it's better, the circuit is basically put back together again, and it can continue receiving requests. So this way, again, it stops those potential points of failures and that potential bottleneck. What all of these patterns tend to enable in reactive systems is this concept of high availability, but eventual consistency. So there are slight trade-offs to this type of architecture, because we have to sort of stick with the CAP theorem. If you don't know much about the CAP theorem, it's all about having this trade-off between three different sort of characteristics: availability, consistency, and I believe the last one is persistence, but I will double check. But there's loads of articles out there around the CAP theorem and sort of why you might want to prioritize some over others. So in this case, it might seem like the end of the world or bad to have eventual consistency, but actually it's probably as close as we'll get to how we operate in our real lives. So for example, you guys might assume watching this presentation that the bees drawn in this are drawn by me. And I'm going to update your sort of state of the world by saying they are not drawn by me, they're actually drawn by my mum. So now you have an up-to-date version of the world, of the state of the world, of the state of this presentation and where we are now. So you're consistent. But everyone else who's maybe seen the presentation online or seen images on Twitter might still assume that I'm the one who draws those drawings. They are eventually consistent because eventually one of you guys might turn around and say, oh no, it's actually her mum who draws them. And they'll become consistent with the state of the system. So we live in this state of eventual consistency where we're constantly updating our state of the universe and we're not always consistent with what everyone else knows, for example. And so in our applications, it's not necessarily the end of the world to have this high availability, eventual consistency sort of model, because what it does mean is that we're able to respond to users and have a better user experience by having this high availability of the information. And this is the type of models that bees also implement. So when we have the scout bee, for example, the scout bee, when he goes to the flower, comes back and dances to the bees. But what happens if in between that scout bee seeing the flower and coming back to the hive, the flowers run out of food? Well, the last bee to come back, then who's basically seen the flower and knows there's no food left, can come back and he essentially headbutts the dancing bee off the dance floor to stop him from dancing. And that's a clear signal to the rest of the listener bees and that scout bee to say, there's no more food left, stop telling them to go there. Now, these bees weren't consistent until that other bee came along and told them there's no more food. So they are eventually consistent. So this is the type of model that reactive systems sort of generally put into place and prioritize this availability of information over the strict consistency models that you may have seen in previous sort of monolithic architecture. So how do you achieve all of these different patterns and all of these different sort of aspects of reactive? Well, there are lots of open source frameworks and toolkits available that you can check out and have a go with. They include things like Vertex, Microprofile, Acroplay, and Lagom are sort of 3 frameworks that are made by the same company. They're all open source and they work together quite well. You've got reactive programming libraries like RxJava, and you've also got Project Reactor. So a lot of these actually build upon this common specification of the reactive streams specification. So the reactive streams was an initiative that started back in 2013, sort of the same time that reactive sort of kicked off, with the reactive manifesto being made in 2013. And it was started by different companies like Netflix, Pivotal, Lightbend, etc. And they essentially started producing APIs for several different languages, including Java. And this API consists of 4 different interfaces. But the point of this was to provide a standard for asynchronous stream processing to allow non-blocking back pressure. And it essentially enables these 4 different interfaces, subscription, publisher, subscriber, processor, to enable publishers to also subscribe to their subscribers. So they can get feedback back from their subscribers to know if they need to slow down the rate of data or the rate of events they're passing through on their data stream, or speed up, depending on the load to those different components and the load to the application in general. So if you want to know more about the individual interfaces, there's actually a blog that we've written about defining the different aspects of reactive, and reactive streams is one of those definitions that we sort of go through, and we go through each of the different interfaces. So you can check out either the reactive streams website itself, which is that top link, or that blog that I mentioned that we've recently published around the specifics. So building on top of this specification, we have several different implementations. Now, users aren't really meant to implement the reactive stream specification APIs without the implementations, because they can be quite tricky, quite complicated, and it can be hard to pass the TCKs. So instead, it's sort of recommended to use these implementations instead. So there are several different implementations, including RxJava, AccaStreams, Project Reactor. So by using these different implementations, you can utilize reactive streams in a much safer environment. So Microprofile is one implementation of the reactive streams, or it uses reactive streams under the cover. So reactive messaging in MicroProfile is just one of the APIs that the MicroProfile stack offers. So if you guys haven't heard of MicroProfile before, it might be worth checking out. It's an open source framework built by multiple different vendors, including IBM, Pyara, Red Hat, and multiple different others, and individuals. So it's a completely open source project, and they're always looking for more contributors. So feel free to check that out if you're interested. These are some of the other APIs that they also offer. So they offer this thing called reactive messaging. Now, reactive messaging builds upon the reactive stream specification that we just talked about, as well as upon another API from MicroProfile called reactive streams operators. Now, the MicroProfile reactive messaging basically uses these annotations on the different beans within your applications. So you've got @incoming or @outgoing annotations. And the @incoming and @outgoing, sorry, hard to say, are connected by these things called channels. Now, a channel is literally just an opaque string. So you can see here, method A is connected to method B through this channel of order. And channels can be internal, so it can be between internal beans within your application, or they can also be external to things like external messaging brokers or databases. You can also use it that way. So this is one implementation that you could use. Another different framework, open source framework, is the Eclipse Vertex project. So this is a polyglot toolkit. So Vertex tends to think of themselves more as a toolkit than a framework because it's a lot more sort of flexible than the sort of more rigid frameworks that you might find. So it enables you to sort of plug in the different aspects of Vertex or the different libraries that you want to use. It's based on the reactor pattern and it runs on the JVM. It's polyglot, as I mentioned, so that means you can use it not just on Java, you can also use it with JavaScript, Groovy, Scala, Kotlin, a bunch of others. Excuse me. And it's non-blocking and it uses this single-threaded nature and it also includes this distributed event bus. So it can be really useful if, for example, when you're using the reactive stream specification, sometimes it can become slightly confusing if you have to individually configure the stream allocation within your application. Vertex is like amazing in this, in that it takes that away from you and has handlers that you can use so that it's able to sort of sort out the thread management under the covers. And you can just focus on the sort of business logic, the application logic in your application, rather than having to build that in. So I'll show you an example later of where we were actually able to use those features to simplify our own application when we were converting to reactive. Another implementation is Akka. So Akka have their own implementation of the reactive stream specification called Akka Streams. That's one of the open source libraries that's offered through the Akka framework. Akka is actually based off a different model. So it's based on the actor model, and actors are sort of a different implementation to microservices. So it's not always a one-to-one mapping between the two. There's sort of a different abstraction level. So you can have multiple actors per microservice, or you could have one actor per microservice. So it's a little bit more to get your head around if you're going to use this type of framework, because if you haven't used the actor model before, it can take a little bit of getting used to just to get your head around it. But Akka then sort of plays really well and works really well with the other tools that sort of like been open sourced, things like Play, which is a web-based framework, and Lagom, which is more like a microservices framework. So that's another implementation that you can use. And you can see here some of the other open source libraries that they offer, including sort of connections to Kafka. So why does any of this matter? What impact will you really get from changing your application and modernizing it into this reactive type architecture? Well, here's a real world example that we have. So Verizon were actually using the Akka framework that I mentioned just now. And what they did was they had this old monolithic style website, and it was causing them all sorts of headaches. So on Black Friday, the website was crashing. Anytime they had a new Apple release, for example, or a new phone release, and they got lots of traffic to their website really slowed down. Their application would crash and come back up, and they had a load of issues with it. And it was really important that they got this application, that they made this application into a more user-friendly, more reliable sort of application or system, because a lot of their sales and a lot of their sort of conversions came through this digital platform as opposed to in-person stores or anything. So you can see here that they had over 88% of their interactions were through this digital channel, and they were making over 2.5 billion in these interactions per year. So it's really important that they updated this software to make it more resilient and more reactive, essentially. So they migrated from this monolithic style into a microservices reactive architecture using the Lightbend stack, so using Akka, Play, Lagom. And what they were able to see when they converted to this reactive style was they were able to get their conversion rate up. So for people visiting the website, they had a much greater conversion from just visiting to actual sales. Their page response times improved, which basically led to better user interaction with their website. But not only that, they were also able to use 1/8 of the infrastructure, which meant massive cost savings for them, as well as their development and deployment time improving massively from 4 to 8 hours to just 30 minutes, which meant their developers were much more productive, and they were able to make more money by having these order completions improved. So overall, not only were customers finding they had better reactivity from the application, the company was saving money by running on less infrastructure. The developers were able to get more done and be more productive with the new technologies, and they were making more money overall. So it was a real win-win-win situation. And you can see here sort of clear figures that show the impact that you can achieve by switching to a reactive architecture. So as I mentioned before, I've taken a previous application that we had based around Kafka, and we decided, okay, we need to do this for ourselves. Let's take a look at what happens when we switch this into being a reactive application. What benefits do we see? So we took this very, very simple reactive Kafka app. It literally is just an application that we've now re-architected to use Vertex. And it does a kind of kooky thing of producing and then consuming from itself. But it's, as I said, a very simplistic app just to test Kafka. And then it connects via WebSocket to this UI that we've created. And you can visit the GitHub there to check it out if you'd like to. But actually, we discovered that we had much simpler thread handling because Vertex was able to manage that all under the cover. And we had a much more asynchronous interaction with Kafka. We were able to implement things like back pressure within our application to build a more elastic and resilient application and have a much more asynchronous style of sort of communication between the different components of our application. You can check out our blog there for a more sort of in-depth review of how we found sort of migrating to this reactive and our journey in that. So you can check that out if you'd like to using the link on the right. If you're the type of person who wants cold, hard facts about why you'd even bother moving to asynchronous and sort of to reactive, and if I haven't proved it enough through my Verizon example, you can check out my colleague Nicholas's blog. He's done an entire blog where he architected an application using Quarkus, which is a runtime that supports the Vertex implementation of sort of reactive. And he looked at Quarkus and used synchronous versus asynchronous. And he actually found that the reactive stack of the sample provided response times that took less than half of the time compared to the old synchronous style that he's done. So the reactive one only took 142 milliseconds to complete, whereas the imperative sort of more synchronous communication to Postgres took 265 milliseconds. So you can check out that blog by heading to the link here for sort of a more code-based and sort of factual comparison between synchronous and asynchronous, and why, again, another reason why you might want to switch to a more reactive, asynchronous natured application, or at least design. So if you wanted to check out some more information on all of these topics, I put some general sort of reactive resources that you can check out here. So the general ones here on the left tend to be more higher level introduction to reactive. So we've got things like my reactive report here. So I authored a really small O'Reilly book. So if you'd like essentially all things reactive systems, check out that reactive report. It takes you through, again, what reactive systems are, why you'd want to use them, and when they might be useful. Or you can check out our very small article, Getting Started with Reactive, which basically links off to loads of different resources where you can get hands-on or learn more about the specifics of reactive systems. Or you can check out the Reactive Manifesto, which takes you through sort of the characteristics that I summarized with the B behaviors. There's also things like the Vertex specification that I used for that previous application. On the right, we've got some microprofile links, so you can check those out if you were interested in the microprofile stack or specifically the reactive messaging component. And then we've also got links to things like Quarkus implementations. So that blog links on the blog from Nicholas links on to a whole series of architecturing an application using Quarkus to be reactive. And we've also got some OpenShift labs there that you can use to get hands-on using Quarkus in a reactive nature. So if you'd like to get hands-on with some reactive APIs, we've got this sort of quick lab type environment. So you don't actually need to install anything onto your device. You can head straight to our reactive Java workshop. It's using our own sort of environment online, and you can pick which module you want. We're adding to this all the time. So in the next couple of weeks, we'll have another 2 to 3 modules added to this around reactive. But if you want to head straight to the first module to get hands-on using some reactive APIs, this module will take you through, I'll restart it. This module will essentially take you through to an online environment, which means that you don't have to download anything onto your computer. You don't need any prereqs or anything. You can just use it in this environment. And this quick lab will take you through using the micro-profile reactive APIs that I mentioned previously. So it's a really great environment to get started, and the steps are pretty simple to follow. This link will be up essentially forever. It won't just be for this workshop. So if you'd like to do this after the workshop, that's totally fine. Feel free to message me if you have any issues with it or anything. We run the site, so we'll be more than happy to fix anything you come up against. I think that's it. So thanks very much for listening. I hope you guys enjoyed it. If you do want to reach out to me, I am active on Twitter, or you feel free to connect on LinkedIn. But yeah, I guess I'll take any questions now.
Thank you, Grace. Animarles a todos a que posten sus preguntas en slido.com. Obviamente, preguntas sobre el tema. No si Grace está disponible. Eso lo pueden preguntar en sus redes sociales. Vamos a comenzar con la primera pregunta de Mala. We have here a question from Mala. It is, did you get a chance to work with the virtual threads fibers from Project Loom?
I haven't yet, actually. It's been something on my list. I really want to try out the Loom stuff because it looks really interesting, especially in regards to the reactive space. So Marla, if you've got any resources I could have a go with, I'd absolutely be up for trying that.
Well, okay. There were another questions if yes, but
sorry,
I guess it does not apply for now.
Maybe if Marla knows, she could answer some.
Sorry? Oh,
if Marla's used it, maybe Marla could answer.
Yes, Marla.
Hi, Grace. So absolutely amazing presentation. I love the images. I think they're all hand-drawn images. I love the emotions that they captured for the bees.
Thanks.
Happy, so very congratulations. So the question was by me because I was kind of reading through the virtual threads in Project Loom, and I was reading how it might change the reactive space. Because now we are not dependent on the system threads, we can have virtual threads. So I just tried out some sample code, so I was interested in asking you whether you tried it out and how would that impact the reactive programming frameworks and certain type of responses, because we were talking about asynchronous working better with the Project Loom and not the synchronous responses. Mm-hmm. So I don't have answer to those questions, so these are the questions for you.
Sorry, I will try and find out, and if I find out, I will definitely post on Twitter, but it's 100% an area that I'm really interested in and want to learn more about, so I'll do some digging.
Thank you.
Okay, thank you. We are going to go with the next question. Greetings from Bolivia. This is from Mateo. Which technology are you using in your event store?
So generally, I tend to use Apache Kafka. So we have our own sort of IBM supported version, which is event streams. So I've been working quite closely with them recently. So the application that I showed you, where I was moving from sort of a synchronous to a reactive application, was a Kafka-based application. So that tends to be the one I use for event storing and sort of my immutable log and everything. I find it's quite a common one people use.
Thank you. Enrico says, greetings from Bolivia. Next question. from Enrique. It's possible to combine reactive microservices with artificial intelligence and machine learning in reactive systems. Do you know any use case?
Yeah, so if you want to check out, my colleague Mary Grigleski has done a whole really fun presentation about combining reactive with AI through Pac-Man. So she's actually been, she's created this whole presentation and this GitHub repo that you can go and check out, where she's just done it for fun, but it sort of helps you take you through why you might want to use reactive with AI and machine learning in sort of a fun and interactive way. In terms of its use cases, it's really in anywhere that you want to be using AI and machine learning, you want really rapid responses, and you want to be able to respond to any event changes or any system changes as soon as possible. So you get the most up-to-date sort of recommendations or up-to-date analysis as possible. So I'd say anywhere that you're using AI machine learning, where you need really rapid responses or really reactive sort of interaction with that AI model, is where you want to implement some of these reactive techniques. But yeah, I will find the link to Mary's presentation and see if I can link that in for you guys.
Thank you. This is from Marcos Marcelo. Greetings. What about performance in real-time process with a reactive system?
Yeah, so if you want to check out Nicholas's blog, it's a fairly simple application, but it shows you that performance change between synchronous to Postgres and asynchronous using those reactive. He actually uses Vertex under the covers for those reactive communications. So he's shown that it's actually the performance increased. So it was, I think it took half the time for the asynchronous response to come back than the synchronous response. So if you check out his blog post on that, you can check out the links to his GitHub repo and you can try it for yourself. But there's definitely a performance increase when using asynchronous communication.
Okay, thank you. The last question from Mateo. When should I build my system in a reactive way?
So I think it's always a trade-off, right? So just like microservices aren't necessarily right for everyone, reactive isn't necessarily right for everyone either. So it's really a trade-off between, do you need in your application, do you need high responsiveness for your users or your customers? Do you want to have cost-efficient, elastic resource sort of reallocation? Do you need to have your application to be really resilient in the face of potential failures? If you're just building a really small application, so if I'm building an application that only I'm going to use, I probably don't care. It's probably quite a small application. I can probably use sort of normal synchronous responses. And if the app goes down, it's only me that it's affected. However, if you're using an application that's built for hundreds of thousands of users or whatever, you've got a large customer base, and you want to provide them with the same good customer experience the entire way through, and you want your application to sort of give the best possible client experience, I'd say that's when you want to start considering, are the trade-offs of re-architecting your application to be reactive going to be worth it for you? And that's sort of where I encourage people to go and check out what it would take to re-architect your application. You can actually check out our Reactive in Practice series, which it's on our IBM developer. Check out Reactive in Practice. And what it does is it moves a monolithic application and it takes you through in 12 different tutorials all the way through to a reactive microservice implementation. So that should give you a good idea of the steps you'd need to take if you did want to convert.
Okay, thank you very much, Grace, for this amazing presentation. As Mala said, it was an amazing analogy between these behaviors and reactive architecture. And well, there is of course an open invitation for future talks, and it's been an honor having you with the Bolivian community.
It's been amazing joining you all. Thank you so much for having me. All the best.
Thank you, Grace. And muchas gracias a todos por sus preguntas, por su participación. Vamos a ir al poll y todos están invitados a participar. Así que, Julio, te cedo la palabra para que presentes el poll.
Okay. procedo a compartir mi pantalla. Los que no hayan entrado al enlace pueden hacerlo ahora. Voy a pasarlo en chat. Ok, estamos saliendo con el QR. Si se pueden unir al enlace. También se ha puesto en los chats de las diferentes redes sociales. Y aquí vamos a ir lanzando el poll. Demos unos minutos para que se conecten. Y comenzamos con las preguntas.
Ok, entonces pueden, para toda nuestra audiencia, pueden escanear el QR o entrar con el código para poder participar del poll. Y recordarles mientras se van uniendo de que pueden participar activamente del Java User Group Bolivia, ¿no? Están abiertas la llamada para que puedan presentar los temas que estén viendo como desarrolladores activos del lenguaje. Vamos a volver a postear las direcciones a las que nos pueden mandar sus propuestas. También pueden escribirnos en nuestras diferentes redes sociales para poder proponer los temas que quieran ver. Algunos de los que se han visto hoy día eventualmente se van a volver a talleres. Vamos a poder ver si vamos a hacer un taller de Reactive o de Mutation Testing, que hoy día hemos estado viendo para profundizar cada una de las cosas que vamos viendo en nuestros meetups.
Ok, procedemos entonces, ¿no?
Dale, Julio.
Va. Pueden unirse al KISS. Se van a entrar al enlace. Hay uno que dice Q&A y el otro polls. Ponen join y se van a unir, ¿no? Perfecto, va la primera pregunta entonces. Entonces, relacionado con la primera exposición de nuestra querida amiga Jazz. Ok, la respuesta era true. Ok. 100% true. Siguiente. Ok, mi respuesta true, verdadero, que es un text block. Y la respuesta era esta. Siguiente. Mientras van respondiendo, cabe resaltar nuevamente que todos los eventos que hacemos son gratuitos. Ninguno necesita algún tipo de pago. Así que pueden unirse. Oh. Records. Esto está relacionado con lo que Mala nos platicaba, ¿no? La siguiente pregunta. El siguiente mes estaremos continuando con la formación para la certificación. En Java 8 más precisamente, Omar nos estará hablando más al respecto. Y espero que este año sí se puedan certificar, ¿no? Ok, veamos la respuesta. Esto es válido en Java 14. La respuesta es message driven. Respuesta Resilient. Siguiente. Respuesta es la primera y la última. Y en primer lugar tenemos a Mateo. Segundo lugar, Rediabel Tintaya Conde. Y tercer lugar, Ricardo Flores. Los tres primeros nos pueden mandar a contacto@bolivianjog.org, por favor, sus datos, sus correos, para que nosotros nos pongamos en contacto y vayamos entregando los premios.
Muy bien, para terminar, quiero agradecer a producción por mi vestimenta y mi maquillaje. No, mentira. Quiero agradecer a nuestros auspiciadores porque hacen posible estos eventos donde podemos aprender y crecer y desarrollarnos profesionalmente. Quiero agradecer a JetBrains, a Mojix, EJ Learner y EJ Technologies y Agile Learner. Muchas gracias por estar con nosotros, por acompañarnos y nos vemos el siguiente mes en el Meetup de agosto. Gracias. Chao, chao.
Bye.